All right, this is day 13 of doing math problems until a Hololive member notices me. So I know what you're wondering. What is the integral on the screen? Right? It's pretty scary and not a fun one at that. But we're going to go ahead and solve this on a whim. So let's just go ahead and get started straight away. So we know that the integral from 0 to infinity of e to the negative alpha x dx is equal to 1 over alpha. And we're going to use this fact, right, to rewrite our original integral as a double integral. So I'm going to rewrite this as the integral from 0 to infinity, and the second integral from 0 to infinity of e to the negative y times x to the n plus 1 dx dy. And I'm going to use a substitution, right? U is equal to y x to the n, where du is going to be y and x n minus 1. And we want to find x to the n minus 1. So we're going to simply isolate x to the n. So we have x to the n is equal to u over y. And we're going to solve for x to the n minus 1. So we're going to pretty much raise everything to the 1 over n. So we have 1 over n. And similarly, we're going to pretty much raise both sides to the n minus 1. So we will have n minus 1 over n for the dx. And pretty much now what we have, right, is pretty much everything in terms of u, y, and n. So I'll just replace x to the n with what we already have. And we will have u over y to the n minus 1 over n. So we got rid of all the dx's, which is very nice. And we're going to simply solve for dx. So we have dx is equal to du over y n, and then I'm simply going to reciprocate, or pretty much have the reciprocal of u over y to y over u. So we have y n and y over u to the n minus 1 over n. So now what we're going to go ahead and do is replace every x that we already have and have y and u. So we will have the integral from 0 to infinity and the 1 over n in the front, because n is a constant. And we're going to have e to the negative y, and what else? Times e to the negative u. Okay, that's not bad. We're making some progress. And it is also going to be times, let's see, how do I write this? Du. Okay, so we have y over n, n minus 1 over n, over y, and we have du dy. Okay, so we're going to simplify this expression right here because we know that y to the n minus 1 over n over y, that is going to just be equal to y to the n minus 1 over n minus 1, which is going to be n over n. So the n's cancel out, leaving minus 1 over n. Okay, so we have y to the negative 1 over n, and the u will pretty much be, oh wait, my u looks like an n. Let me just fix that. So we're gonna also look at this, and this will pretty much be u to the 1 minus n over n, which I will just rewrite as 1 over n minus 1. Okay, so now we have an integral with u and y. So we can pretty much write this as a product of two integrals, okay? And I will write this as 1 over n times the first integral, right, which I will probably have to be y. So we have e to the negative y times y to the negative 1 over n dy, right? And since we have u, it's going to be multiplied by the integral from 0 to infinity of e to the negative u times u to the 1 over n minus 1 du. All right, so our first integral, right, this one, is going to be the gamma function of, as we have the power is negative 1 over n, it will be 1 minus 1 over n. And the second one will be the gamma of, since it is 1 over n minus 1, it would just be 1 over n. Okay? So, and it's also multiplied by 1 over n, so let's not forget that. So pretty much all these three are now just in terms of n. And we're going to use Euler's reflection formula for pretty much this and this, right? Because they're both multiplied, which pretty much will give us pi times cosecant of pi over n. And since it is divided by n, we will have this. So pretty much after all that, right, we see that our integral, our original indefinite integral is pi over n times cosecant of pi over n. So this is actually pretty good for us because we at least now are able to see that it's not that hard. It's just a bit of knowledge on gamma functions and manipulating around everything. And yeah, so pretty much all this took was just a simple integral identity and then one u sub, and then manipulation, and then converting everything into the gamma function, then using the Euler reflection formula to get the pi cosecant pi over n. And yeah, all the work was done algebraically. So woohoo, we did it. So yeah, that's our work here. And yeah, thank you for watching this. And I will say bye bye.